Good morning, everyone online. I'm pleased to have been invited to this year's EAVLD virtual conference to present the cattle TB vaccine project on behalf of the entire project team at the Animal and Plant Health Agency in the UK. So this project really aims to generate and collate all required data necessary to apply for a marketing authorization for a cattle vaccine and an associated DIVA skin test to be used against bovine tuberculosis. I myself joined the project 2 years ago in the role of a scientific project manager. Before I start, I'd like to give a very brief overview of what I'm planning to talk about over the next 20 to 25 minutes. I will start with giving a background to bovine tuberculosis and the current situation in Great Britain. I will then talk about the cattle BCG vaccine we have available and the DIVA skin test, which has really been the pivotal development in moving towards enabling vaccination against bovine TB. I discuss the requirements to gain marketing authorization for cattle BCG and the DIVA skin test reagent, and then briefly talk about field trials, which have to be run to produce safety and specificity data for both cattle BCG and the DIVA skin test reagent. Bovine tuberculosis can be caused by bacteria of the Mycobacterium tuberculosis complex, and this includes Mycobacterium and tuberculosis. In the UK, it's mainly caused by Mycobacterium bovis, and it can occur, amongst others, in domestic livestock such as cattle, goats, buffaloes, and camelids. In the UK, the badger serves as a wildlife reservoir, and I think in France and Spain, wild boar takes the role of the badger in the UK. There's also other wildlife such as the white-tailed deer or Australian bush-tailed possum that can be infected by M. bovis. I thought I'll also mention that bovine TB is a zoonotic disease and is indeed listed by the World Health Organization as one of 7 neglected endemic zoonoses. Infection mainly occurs through consumption of unpasteurized milk and cohabitation with infected animals, so it's not really a big issue nowadays in the UK or in most countries of Europe since the introduction of pasteurization of milk in the early mid-last century. However, in other countries of the world, such as Africa or India, it still causes a risk to human health. And I just thought it's also worth mentioning, just to highlight, that if left uncontrolled, it could turn into a risk for the public. On this slide, I'd just like to give a brief overview on what is the current situation in Great Britain. And on the right-hand side, I have a figure that shows the national spread of bovine TB since 1986. In red, the red dots are representing the number of cases. So you can see that from 1986 to 2010, there was an increase from 235 cattle testing positive for bovine TB to more than 28,000 in 2010. Unfortunately, that figure ends here, but I found another one which doesn't show the amount of cattle testing positive for bovine TB, but rather it shows the increase of number of herds under disease restriction. And it shows a similar picture. So from March 96 to March 2020, number of herds under disease restriction went up sharply until March 2012. And then the situation sort of stayed steady from 2012 to 2019. And in the last 2 years, it almost looks as if there was a slight drop in number of herds under disease restrictions. On the left-hand side, you see a map of Great Britain, and it shows the division of England and Wales into 3 risk areas, which are directly linked to prevalence of the disease and require different surveillance measures. So in green, you have the low risk area with the lowest prevalence of disease. Then in yellow and black, there's the so-called edge area. And in blue is the high risk area with the highest prevalence of disease. And a similar classification is in Wales, which you can see in purple here. And in orange up here, there's Scotland, which is officially TB-free. Bovine TB is controlled in GP there's a test and slaughter program in place, and from June 2020 to June 2021, more than 30,000 animals were slaughtered. Positive animals are picked up through using the skin test, the single intradermal cervical comparative tuberculin test, or short SICT. This is the primary disclosing test for bovine TB in Great Britain. Since 2006, we also use the gamma interferon blood test, also known as the Bovigam test. And this is really a supplementary test used in addition to the SICT skin test. And it really aims to identify infected animals that haven't been picked up by the SICT test. Annual number of herds not officially TB-free unfortunately remains high. So in June 2021, there were still 2,430 herds in England classified as not officially TB-free, and this really highlights the requirement for additional control measures necessary. And the government realized that several years ago and developed a strategy for achieving officially bovine tuberculosis status for England by 2038 or 2038. And there they list additional control measures for surveillance, breakdown management of infected herds, ways to deal with the risk of TB from badgers, and other disease preventions. But very importantly, they also mentioned cattle vaccination using the currently available BCG vaccine as one of the tools to decrease the burden of disease in the UK. The vaccine we use is BCG, Bacillus calmette-guerin. That is really the same vaccine as used in human and was developed by Albert Calmette and Camille Guerin in the early 20th century. It is a live attenuated vaccine derived from Mycobacterium bovis through passaging it 231 times on ox viral media. And through these passages, the region of difference 1, which is a 9-gene region, was deleted, leading to loss of virulence of the BCG vaccine strain compared to the M. bovis strain. In the UK, or in our studies and in the planned rollout, we use BCG Danish 1331 and administer it subcutaneously. The standard dose for cattle BCG is 1 to 4 times 10 to the 6 culture forming units, and this is equivalent to 5 human doses. We know from experimental studies and also studies in the field that vaccination provides variable protection in cattle. At APHA, Martin Vordermeier and his team have developed an endobronchial infection model, which allows them to look at the efficaciousness of BCG vaccination in cattle. And I thought I'd just very briefly explain to you how this model works. So they use Holstein Friesian calves, vaccinate them with BCG, keep one set as control animals, then they wait 3 months and then infect the vaccinated animals and the control animals with Mycobacterium bovis. Then they keep the animals for 3 months, during which time tuberculous lesions can develop in infected animals. And these lesions really mimic a natural disease. And then after 3 months, the animals are killed and post-mortem analysis takes place. And during post-mortem, the lungs, the head and respiratory associated lymph nodes are analyzed, and they've put together a quantitative scoring system which allows to score the severity of pathology in the lymph nodes. And down here you can see pictures of a cut lymph node from a BCG vaccinated animal where there's no pathology visible. And then on the right hand side you can see what a lymph node looks like when pathology is there in an infected animal. At APHA, 6 studies have taken place looking at the efficacy of BCG vaccinating, and they showed that there's been an average reduction of 70% of severity of visible pathology scores in BCG vaccinates. We see a spectrum of protection. So there's some animals that are fully protected and have no visible lesions. There's animals that are partially protected, where we see a reduced pathology score compared to the non-vaccinates. And then there's some animals that are not protected at all and show a similar pathology score to the non-vaccinates. Very importantly, it's also been shown that BCG vaccination protects against naturally acquired bovine TB. And there have been 2 studies in New Zealand in the field, one where they orally vaccinated the animals and one where they subcutaneously vaccinated animals. And in the study where they used the oral vaccine regimen, they could see that there was a protective efficacy for vaccination of 67.4%. And in the study where they chose the subcutaneous route of vaccination, they showed a protective efficacy of 85.7%. So you may ask yourself, why is the vaccine not in use already? And this is really because BCG vaccination does not provide full protection in all animals vaccinated. And that means that we are still required to perform surveillance testing to detect M. bovis infection. And the issue here is that BCG vaccination primes the immune response to antigens contained in bovine tuberculin skin test reagent, which forms the basis of the current diagnostic tuberculin skin test, the SICKET. And the SICKET is not able to distinguish between an infected and or vaccinated cow. And because of this lack of a DIVA test that would be able to detect an infected amongst vaccinated animals, current legislation in the EU does not allow to vaccinate cattle and would prohibit the UK to trade vaccinated animals and possibly meat products with the European Union. And therefore, the cattle BCG has really not been authorized yet, and until there is a marketing authorization for the vaccine, we cannot use it in the UK. A game changer has really been the development of a DIVA skin test, which was developed by Gareth Jones and his team at APHA. And this DIVA skin test really allows to identify individuals where vaccination is not protected from disease. So DIVA in our case stands for Detect Infected Among Vaccinated Animals. The DIVA skin test reagent is DSTF, where F stands for fusion protein. So it's a fusion protein consisting of 3 defined antigens, and they are targets of the immune system in Mycobacterium bovis infected animals, but not BCG vaccinates. And the 3 antigens are ESAT6 and CFP10. Both of these genes are deleted in the vaccine strain BCG. And then there's RV3615C, which is present in BCG, but the gene product is not secreted. This slide summarizes all the performance data available for DSTF from experimental studies. And on the left-hand side, you can see the specificity of DSTF and the SICKET in BCG vaccinated and unvaccinated controls. And you can see that both DSTF and SICKET are highly specific in unvaccinated controls. In BCG vaccinates, DSTF has a specificity of 99%. So out of 70 animals, BCG vaccinated animals, there was 1 false positive. In the SICKET, in the same animals, looking at the SICKET results, however, there's only a specificity of 78%. And on the right-hand side, you can see the sensitivity of DSTF and SICKET in M. bovis infected animals and BCG vaccinated and experimentally infected animals. And you can see that DSTF in M. bovis infected animals has a sensitivity of 92% compared to 84% sensitivity of the SICKET. And in BCG vaccinated and then experimentally infected animals, DSTF sensitivity goes down to 85%, and the SICKET is very similar at 81%. Having a vaccine and a companion DIVA skin test really opens the door to using vaccination as one of the tools to reduce the disease burden in future in England or Great Britain. And cattle BCG and DSTF are both classified as immunological veterinary medicinal products, short IVMP. And to sell an IVMP on the UK market or to use it on the UK market, a marketing authorization granted by the Veterinary Medicines Directorate is required. And this marketing authorization is really there to ensure that the safety of the product to the target species, the operator in our case, that would be the vet who administers the vaccine and the Diva skin test, safety to the environment, companion animals, and the human consumer are ensured. It also ensures that the products are used are efficacious, and also ensures that the products are produced to a certain quality standard and adhere to certain quality standards. So the safety and efficacy data is initially generated in laboratory studies, and then eventually safety data has to be demonstrated in the field. To run veterinary field trials in the UK, an animal test certificate is required, and this is granted by the Veterinary Medicines Directorate. The table on this slide shows all the data and experiments that we had to submit to the regulator as part of the animal test certificate application. And you can see that there was quality data and manufacturing data that had to be provided for both the DSTF and BCG, safety data obtained through laboratory studies, risk assessments had to be provided for BCG. So there was one that looked at the risk to public health through consumption of meat and milk products, and the second one that looked at the environmental risk coming with BCG vaccination. And this is really required because BCG is a live attenuated vaccine. We also provided data on efficacy and performance of DSTF and BCG, and the design or planned design of the field trials had to be submitted. The ATCs were granted by the Veterinary Medicines Directorate in July 2020, and that gave us the green light to progress with planning of the field trials. The first step in moving forwards with the field trials was to appoint a contract research organization, CRO, to conduct the field trials on behalf of APHA, and that happened in December 2020. And there are two stages to the field trial, or phases as we call them. So there's phase 1, looking at DSTF in non-vaccinated controls, and phase 2, where we look at the safety of cattle BCG and DSTF specificity in vaccinated animals. So in more detail, what is phase 1 of the field trials looking at? So to start with, these trials are ongoing, and we are looking at investigating the specificity of DSTF in a large number of unvaccinated cattle. The second objective is to confirm the safety of DSTF in cattle. A minimum of 300 animals and up to 1,000 animals, depending on the number of false positives, will be administered DSTF. And we are looking at various categories to look at safety of the product. So we look at beef, dairy, calves, pregnant and lactating cattle on a minimum of 5 farms. The farms are all in low risk area of England and Wales, so the green parts on the map here, or this dark purple in Wales. The target specificity for the cattle Diva test is 99.85. That means we can have 1 false positive in 300 animals. And if we have more than 1, we'll have to extend the numbers of study animals to a maximum of 1,000 and would be allowed 5 false positive animals. Just to mention, the field trials are run according to good clinical practice, and this is really a standard for the design and conduct of clinical studies of veterinary products in the target species to ensure that one is keeping to certain scientific and ethical standards. We hope to complete phase 1 field trials early next year, and will then proceed to phase 2 of the field trials, or stage 3 in this figure, in May 2022. Objectives of phase 2 of the field trials are to confirm the safety of cattle BCG under field conditions and to collect DSTF specificity data in vaccinated animals. We'll be looking at herds that are currently officially TB-free, and similar to phase 1, we'll start with a minimum of 5 farms, with a minimum of 300 vaccinates and 300 control animals. In addition to the field trial data and the data I showed earlier, which was part of the animal test certificate application, we need further efficacy data and performance data for the vaccine and DSTF. So there's currently a duration of immunity study running at APHA. It's a laboratory study in minimum age animals using cattle BCG at minimum titer. Cattle have been vaccinated in summer this year and will be challenged a year later, and results are expected by the end of 2022. We also have a DSTF sensitivity study ongoing, where we establish the sensitivity of DSTF in naturally infected cattle. So if you remember, I showed data on a previous slide for the sensitivity of DSTF, but this was in experimentally infected cattle. A big part of the ongoing work is also to appoint a contract manufacturing organization, CMO, to produce DSTF according to good manufacturing practice standards. So DSTF has been developed by APHA together with the biotech R&D company Lionex, which are producing the DSTF for the field trials, but they don't have GMP facilities. So once a CMO is appointed, the technology will have to be transferred from the current producer Lionex to the CMO. We'll then have to demonstrate bioequivalence of the GMP-produced DSTF batch to the Lionex batch, and then also 3 consistency batches will have to be produced before we can apply for the marketing authorization. And if the consistency batches are available in time for phase 2, we may also use one of these batches in phase 2 of the trials. This is not a prerequisite to gain marketing authorization, but would be advantageous. This table is really just to show that for the marketing authorization application, we already have most of the data, which was part of the animal test certificate application. In addition, we'll have to provide more data for DSTF, quality data as discussed on the previous slide, and the data on the DSTF sensitivity study and the duration of immunity data. And the field trial design has now changed to the available data, which will have to be submitted. Having all the data available, we can then start thinking about compiling the marketing authorization application dossier. There will be 2. There will be one for cattle BCG and one for DSTF. And we hope to submit the one for cattle BCG in 2023 and the one for DSTF in 2024 at the latest. And finally, to summarize, so we have a cattle vaccine, we have a DIVA skin test reagent, which allows detection of infected among vaccinated cattle. We have laboratory data to confirm safety and efficacy or performance for cattle BCG and DSTF. We have an animal test certificate that was granted by the regulator in 2020. Phase 1 of the trials are ongoing, looking at DSTF specificity and safety in the field. We are in the process of appointing a contract manufacturing organization to produce DSTF according to GMP standards. We hope to start in May next year, phase 2 of the field trials, where we'll generate safety data for cattle BCG and specificity data of DSTF in vaccinated animals. Technology transfer of DSTF from an R&D biotech company to a GMP certified manufacturer will go ahead next year. We'll be then able to compile the marketing authorization application dossier and submit in 2023-24. Providing the MAs are granted, the vaccine and DIVA skin test can be rolled out in England and Wales. And once that happened, ongoing monitoring of test diagnostic accuracy and ongoing pharmacovigilance will be required. To finish off, I'd just like to acknowledge a few key people. So there's Nick Colden, the Senior Responsible Officer to the project, Martin Eilert, who's been the project lead for the last year and was really pivotal in moving the field trials forward, Phil Hogarth, our TB lead scientist at APHA, and obviously Gareth Jones and Martin Fordemeyer, the scientists that have run the DSTF and BCG cattle studies. Many thanks for listening, and I'm more than happy to take any questions later in the question and answer session.